Okay, graphing equations with two variables. We're going to jump right into an example. It says, suppose your soccer coach emails your team about an optional practice, and there are 12 people on your team. If a given number of people can make the practice, how many cannot? Complete the table to show the possible answers. Okay, so if 0 people can make practice, that means 12 cannot. If 1 person can, 11 people cannot. If 2 people can, how many cannot? 10. If 3 people can make it, how many people cannot? 9. Okay, and then it just says to complete the table to show the possible answers. Okay, there's not enough spaces to show all the possible combinations, so let's just pick some. What if 6 people can make it to practice? 6 people cannot. What if 12 people can make it to practice? 0 could not. Okay, what if 4 people can make it to practice? Then 8 cannot. So it says you can write the answers in the table as ordered pairs x, comma, y. Let x equal the number of people who can make practice. Okay, so this is going to be our x, and y be the number of people who cannot make practice. The ordered pair 9, 3 means 9 people can make practice and 3 people cannot. Write 3 other ordered pairs we can make from the data. Okay, so we can just come up here. I could say 0, 12. I'm going to pick 2, 10, and I'm going to pick 4, 8. Okay, and now it says graph each ordered pair and describe the pattern of the points. Okay, so this is people who can, and this side is people who cannot. Okay, so I'm going to count, let's see, by twos. I'm going to say 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. Okay, so if 0 people can come to practice, then 12 people cannot. That would be my dot. If 2 people can come to practice, 10 people cannot. If 4 people can come to practice, 8 people cannot. Okay, what if 12 people can come? Then 0 people can't. What if 10 people can come? Then 2 cannot. Okay, so it says describe the pattern of the points. Okay, and so this pattern is that as the number of people who can come increases, the number of people who cannot come decreases. Okay, so we can say as the number of people who can come increases, the number of people who can't decreases. I ran out of space. So it says you know how to solve equations with one variable, right? That's what we did last chapter. Now you'll solve and graph equations with 2 variables, such as the equation x plus y is 12, right? This equation right here would represent what we just graphed. The people who can plus the people who can't has to equal 12, right? 0 people can, 12 people can't, that's 12 people total. And then it says any ordered pair that makes an equation true is a solution of the equation. For example, 9, 3 is a solution of x plus y is 12 because 9 plus 3 is 12. So it says determine whether each ordered pair is a solution of y equals 3x minus 4. Okay, so remember it's always x and then y. So y has to equal 3 times x minus 4. So this y is 10. So that needs to equal 3 times 5 minus 4. So what's 3 times 5? 15. 15 minus 4 is 11. Does 10 equal 11? No. So this is not a solution. Okay, look at the next one. It's the same equation. Y equals 3x minus 4. So does negative 10 equal 3 times negative 2 minus 4, right? I'm plugging in y and x. So negative 10 equals negative 6 minus 4, right? If it helps you, think of it as keep, change, change. So does negative 10 equal negative 6 plus negative 4? Yes. So this one is a solution. Okay, look at the next one. We have 14 equals 3 times 6 minus 4, right? I got that from 3x minus 4. So 14 equals 18 minus 4. What's 18 minus 4? 14. So 14 equals 14. So this is also a solution. So why don't you check negative 6, negative 14, and then come back and we'll see if you got it right. Okay, so y equals 3 times x minus 4. So negative 14 equals negative 18 minus 4. Well, negative 18 minus 4 is negative 22. So negative 14 does not equal negative 22. So that one is not a solution. Okay, look at your next page. It says you can find a solution to an equation with two variables if you know the value of one. So it says suppose you saved $38. In the equation y equals 38 plus 4x, y is the amount you have saved after x weeks if you save $4 a week. Okay, this kind of goes back to those word problems that we did at the end of your last test. So you already have 38 and then you're getting $4 a week, right? So y represents the total that you have. So it says complete the solution 12 comma blank to find how much money you'll have after 12 weeks. So y equals 38 plus 4 times x, and we're given x is 12. So that's y equals 38 plus 48, which is 86. Okay, and now it says for how many weeks will you have to save if you want to have 200? Okay, so I know that it's going to be 200 equals the 38 I already have plus 4 times however many weeks, right, that I'm going to save. So I'm going to take out the 38 that I already have, which is going to give me 162 equals $4 a week. Are we good with that part? Yes. Okay, so now we're going to do 162 divided by 4. 4 goes into 16 4 times. That's 16. Bring down a 2. 4 goes into 2 0 times. Whoa, I'm running out of space. Bring down a 0. 0.5. Okay, so 40.5. But can you save for half a week if you're getting $4 a week? No. So we're going to save for 41 weeks. Because 40 wouldn't be enough, right? Okay, it says use the equation y equals 3x minus 2 and complete each solution. So the y value is what's missing, and it's going to be equal to 3 times whatever the x is minus 2. 3 times 2 is 6. 6 minus 2 is 4. The y is going to equal 3 times whatever the x value is minus 2. 3 times 5 is 15. 15 minus 2 is 13. Y equals 3 times whatever x is minus 2. 3 times negative 5 is negative 15. Negative 15 minus 2 is negative 17. An equation with two variables can have many solutions, right? For this 3x minus 2, 2, 4 is a solution, 5, 13 is a solution, negative 5, negative 17 is a solution. It can have tons of solutions, and you can show these solutions on a graph. The graphs of linear equations, okay, which is what we just did, 38 plus 4x, y equals negative a half x plus 2, are going to be on a graph. And to graph linear equations, we're going to start by making a table showing several solutions. We're going to graph those solutions as points and then draw a line through the points. Okay, so step 1. here's our table. Okay, we're going to try to graph y equals negative 1/2 of x plus 2. So you get to pick the x values. Okay, what if I put a 0 in here? Negative 1/2 times 0 is 0. 0 plus 2 is 2. That's the point. 0, 2. What if I picked the point 6, or I picked the x value of 6? Negative 1/2 times 6 is negative 3, plus 2 is negative 1. So I have the point 6, negative 1, right? Because 1/2 of 6 is 3, and it's a negative times a positive, so it's a negative. Well, what if I picked negative 6? 1/2 of 6 is 3, but it's a negative and a negative, so that's positive 3 plus 2 is 5. So that's the point, negative 6. 1, 2, 3, 4, 5. Okay, and what I'm going to do is I'm going to go ahead and connect my points because I want to show you something before I do the others. I should have used a ruler. That's okay. Okay, so we're connecting these with a line, and what I want to show you is that it doesn't matter what values you pick for x, everyone's going to get the same line. Okay, so let's say I picked positive 4. Negative 1/2 times positive 4 is negative 2. Negative 2 plus 2 is 0. So when I plugged in a 4, I got 0. And if I'd drawn that with a ruler, it would have been right on my line. Okay, what if you'd picked, I picked all even numbers here because since I'm taking 1/2 of it, that's easier to take 1/2 of an even, but I didn't have to. What if I had picked negative 5? 1/2 of negative 5 is 2.5, and negative is positive, plus 2, that's 4.5. So negative 5, 4.5. That's right on my line. So you could have totally different x values than someone else, and you still get the same answer. So let's look at this one. Graph y equals negative 3x plus 2. So again, we get to pick our x values. I'm going to pick 0 first because that's easy. Negative 3 times 0 is 0. 0 plus 2 is 2. So I have the point 0, 2. Well, what if I put in positive 4? Negative 3 times positive 4 is negative 12. Plus 2 is negative 10. So, whoa, that's 4. And then negative 10. Okay, so what if I put in negative 3? Negative 3 times negative 3 is 9. 9 plus 2 is all the way over here at 11. Okay, so negative 3, I'm just going to go up to where 11 would be. So check it out, right? They're in a row, but look at how spread out they are. Let me use this ruler thing. My versatile box. Hold on. Oh, it's not straight. Never mind. Okay, so if I connect these, good enough, right? That's my line. Okay, so look, it does not matter what you picked. Let's say I had picked positive 1. Negative 3 times positive 1 is negative 3. Negative 3 plus 2 is negative 1. 1, negative 1. Magic. It is on my line. Okay, let's say I had picked negative 2. Negative 3 times negative 2 is 6. 6 plus 2 is 8. Negative 2, positive 8. There you go. Okay, the last example, I'm going to give you a little hint. If you are multiplying by a fraction, okay, the easiest thing is going to be to pick multiples of 3. Okay, and I'll show you why. So I'm going to pick like 0, I'm going to pick 6, negative 6, 3, and 9. Okay, so 2/3 of 0 is 0. 0 plus 1 is 1, right? That's an easy one. So if I'm taking 2/3 of 6, okay, so 6 over 1 times 2 over 3. So 6 times 2 is 12, divided by 3 is 4. 4 plus 1 is 5. So I have the point 6, 5. Well, what if it's negative 6? Negative 12 divided by 3 is negative 4, plus 1 is negative 3. So negative 6, negative 3. Well, what if I picked 3? So 3 times 2 over 3 is 6 over 3, which is 2. 2 plus 1 would be 3. So I have the point 3, 3. And look, I can see it's going to make a line. And then what if I picked 9? 2/3 times 9, that's 18, divided by 3 is 6. 6 plus 1 is 7. So when I put in 9, I got out 7. Okay, I'm going to connect these with a line. Okay, and just for fun, let's say I had picked negative 9. That would have been negative 6 plus 1 is negative 5. Negative 9, negative 1, 2, 3, 4, 5. Whoop, it should be on my line if I'd drawn it straight. So it doesn't matter what x values you pick, but pick values that are easy to use in your tables, right? If I had picked 5, I would have had 2/3 of 5, which would have been 10 over 3. So 3.3 repeating plus 1 is 4.3 repeating. So I would have had 5 and then 4.3 repeating. It just is going to be harder to do, right? Those points are still solutions, but if I can pick convenient x values, that's going to help when I'm doing the math to find the y's.